Okay guys, I have picked a couple of problems from the review to go over with you, and specifically in this video I'm focusing on the problems that require the use of the calculator, just to kind of help you out with that. So this would be what would be on the day 2 part of the test, or Friday's part of the test. So I picked 20, 22, so let's kind of go over those. And when I look at this problem here, I see that I have log on the left and log on the right, but the problem is I have this 1/2 out front. So I have to bring the power up first. So the very first thing I'm going to do is bring the 1/2 up as a power. That's one of our properties of logs. And once I have that, I can just set x plus 3 to the 1/2 equal to 4 because of my equality properties. So once I do that, I would simply square both sides to get the x plus 3 all by itself, and then I get 16 on the right, and then I would just subtract 3. So I'm going to get 13 for that one. Okay, number 22 is one that we talked about in class, that there's several different ways to do this. I'm going to just take the log of both sides, so I'd insert a log here and a log here, and that allows me to bring the x minus 5 out front. So here's the x minus 5 out front of the log of, should be 14 actually, 14, I made a mistake there, okay? So then this would also be a 14. Okay, so then I would divide both sides by the log of 14, and then I would add the 5. So I'm going to do this in the calculator just to make sure, because I made that mistake there. So in the calculator, it's going to be the log of 625, close your parentheses, divided by the log of 14, close your parentheses, get that value, and then go ahead and add 5. And you're going to get 7.439. So that is the correct answer. So this would be exact form, where I leave it in log form, I don't plug anything in the calculator, and then this would be approximate. So on the test, you're going to be asked at different times for exact and at different times for approximate, so you just have to follow those directions. Okay, number 23. When I look at this, it is an exponential equation. My unknown is the t here in the exponent, and I want to solve for that t. Before I can use like any of my different methods, I have to divide both sides by 4. So I'm going to have to go ahead and do that. And I do that so that I can isolate the e to the power there. So anytime you have a power with a coefficient out front, you have to do division to get rid of that. So I'm going to end up with 17 is equal to e to the 0.045t. And remember, I want to solve for that t. So I could take the natural log of both sides, and that's going to be pretty straightforward. I could rewrite it as a logarithmic using the natural log, but I usually just go ahead and do the natural log of both sides. And then this will come down front, and remember, it will just be multiplied by ln of e, which is just the number 1. So that will be ln of 17. And you can see to solve, I would just divide both sides by 0.045. 0.045. So it's going to be ln of 17 divided by 0.045. And that is going to give me approximately 62.96. All right, so the rest of those are similar. The only thing I will tell you is that if you have a problem like this, where you have a power out front and you're trying to condense it down to one log, you have to deal with the power first. You have to bring the power up. And remember that the power will only apply to the log that is actually associated with. So this would be log base 7 of 2 cubed, or 8. And this would be log base 7 of 27 to the 1/3, where that would simplify down to a 3. Then you can multiply the 3 with the 8 and set that equal to the square root of x. So make sure to do that problem. But I've specifically picked these problems after looking at the test, just making sure we're covering everything. All right, so number 26. Find the amount of time required for 500 to triple if it's invested in an account that earns 6.75% interest compounded continuously. Okay, what I'm going to show you now is the little slip that you'll be given on test day. So when you have a problem like this and it says continuous compounding, it's going to be this formula right here. So continuous compounding goes right here. I had to abbreviate it there. Okay, so we're going to use A is equal to P times e raised to the r times t. So A is equal to P times e to the r times t. Now, I called that the PERT formula in class, but that's pretty much what you're going to do. So I want to invest 500, and I want it to triple, and I want to know how long, so I'm solving for t. I want to know how long that's going to take at a certain interest rate. So I'm going to basically start with 500, and that will grow or triple to 1,500. I have E, I have 0.0675. Recall you have to put that in decimal form times t. And then the first thing I'm going to do is divide both sides by 500. So you see you're going to basically get down to where you're starting with 1, ending with 3, which is the same ratio, the same relationship. So that is where we are now. What I'm going to do next is I'm going to take the log of both sides. So when I take the log of both sides, I'm going to use ln, of course, because my base is e. This will come out front, so it'll be 0.0675t times the natural log of e, which is just 1, and then ln of 3. So to leave it in an exact form, I'm just going to divide both sides by 0.0675. So t is going to be exactly ln of 3 divided by 0.0675. That's the exact form of the answer, but if I want to approximate it, you can do that in the calculator, of course, and I'm going to get 16.276 years. Okay, so make sure you understand that type of problem, and the main thing about this problem is you're given an amount and you're told that it triples. So you don't know the ending amount, but you know that the relationship is 1 to 3. You may not even be given the initial amount, but if you know that the amount doubles or triples or quadruples, you know the relationship would be 1 to 2, 1 to 3, 1 to 4, respectively. So that's kind of how you would approach that. All right, so the next one I'm going to do is number 30. And this sort of seems like the case of the cooling corpse that we did. So I'm going to actually grab a separate sheet of paper for this one. So as I read through this, the coroner arrives at 12 p.m. That's important because that's what time I think the temperature is initially taken. So the initial temperature is taken or found to be 94.6. So the coroner takes the temperature 1 hour later, so that's the elapsed time, and finds it has dropped to that amount. So the temperature of the room is 70 degrees. When was the murder committed? Okay, so basically we're going to kind of work backwards to find out when the temperature was 98.6. But before we can do that, we have to find our cooling rate. Okay, so basically let me kind of set this up for you. So this is number 30. I just ran out of room there. So I know I have a temperature of 94.6, and that's at 12 p.m. I have a temperature of 93.4, and that's at 1 p.m. So the elapsed time is 1 hour. So the temperature of the environment is going to be 70 degrees. Okay, now I want to go back to our little formula sheet that I was talking about earlier. So this is what we're talking about here. So this is Newton's law of cooling. So Newton's law of cooling. And we did some of that in class, so you know where that, how we would use that. So let's go back to the problem. Now what I want to do is I want to basically think of these as almost like data points, or think about the fact that in 1 hour's time, the temperature dropped. So I can use that to find my cooling rate. So my ending temperature is 93.4. The temperature of the environment is 70. And it's going to drop from 94.6. So that's my initial temperature. So think of that, that's my initial temperature right there, T sub 0. So 94.6. And then that has to be compared to the surrounding temperature, and then I have E to the negative K, and then T is just going to be a 1 because it's 1 hour, okay? So that's kind of the setup there. So the temperature starts at 94.6 because the room is cooler than the body temperature. Within an hour's time, it's going to drop to 93.4, okay? So I'm going to simplify this down a little bit. So basically, we did some of this in class, but you're going to want to subtract over the 93.4. Actually, yeah, that's fine. We can do it that way. So we're solving without the calculator, because I think the first time we saw this, we did the graph. I'm going to actually subtract 70 this way, and I'm going to get 23.4 here. And then I'm going to go ahead and get my coefficient here of 24.6, and then I e to the negative k times 1, of course. Okay? So to solve for this k, the first thing I need to do is divide both sides by 24.6. Because I want to basically get the power isolated so I can take the log of both sides. So that's where I am now. So I'm going to now take the natural log of both sides. 23.4 over 24.6 is equal to negative k times the natural log of e. That's just going to be the number 1 there. Okay, so to solve for my k, I'm going to end up basically just dividing by a negative 1. So k is going to be equal to a negative ln of 23.4 divided by 24.6. That is exact. And when I plug that into the calculator, remember how we said we're going to store that. So let me go to the calculator. So I'm going to do negative ln, and in parentheses, I'm going to have 23.4 divided by 24.6. And I'm going to get that value, and I'm going to store it as my k. Remember my k, I'm going to turn on the little alpha green button so I can store it as k. So there it is as k. And I don't really even need to know, but it's roughly 0.0500. Now I wouldn't really write that down to any great detail. I just want to kind of show you approximately 0.0500. I'm not actually going to use that value though. I'm going to use where I stored it in my calculator, so I'll make sure. So yes, there we go. All right, so back to this. So I know my k, and now what I'm going to do is I'm going to go back and I'm going to figure out how long it would take, basically working backwards almost, for the body temperature to get back to 98.6. Okay, so going back to the equation, but now that we know k, I'm going to basically say now we're dropping from 98.6 degrees at the time of death, and then that's going to drop down to 94.6 when he was initially, the temperature was initially measured. Okay, so I know this happened at 12 p.m. All right, so putting all this into place, 94.6 is my ending temperature. My surrounding environment is 70 degrees. I'm starting at 98.6. Subtract your 70 and e to the negative k and t. So when I look at all this, the only unknown I really have is the t. I just have to kind of tidy this up a little bit. So again, I'm going to subtract 70 over, and that's going to give me 24.6. And that's going to give me an a value of 28.6, e to the negative kt. So I'm going to divide both sides by 28.6. And then I'm going to take the natural log of both sides. So I'm down to, on the right side, it's kind of hard to see, but negative kt natural log of e. That's just the number 1. This is in my calculator. So to find t, I'm going to divide both sides by negative k. So ln of 24.6 over 28.6 divided by negative k. Now, this is exact. That's exact for time, but I'm going to go do it in the calculator, and I'm going to get the approximate for this one. This one I need. That one up here I didn't really need the approximate for k. Okay, so let's do that in the calculator. So I'm going to have ln of 24.6 divided by 28.6. And then I'm going to get that value. I prefer to go ahead and get that value and then divide by negative and just recall the negative k. And so the time is going to be roughly 3.01257. So what we're going to have to do with that is we're going to have to figure out what that means in terms of time. So 3.012, 3.013. Okay, I am going to pick up, I had to pause the video for just a second, but I'm going to pick up with number 4 under the sequences and series. And again, I want to talk about the formulas that you will have the day of the test, or both days of the test. So we're dealing with this bottom row. This is arithmetic explicit. This is geometric explicit. So this is basically the sequences formulas that you've used in the past. And then this formula here is for summing, or for the series of an arithmetic. And of course, that can be done only through a finite term, like the nth term, for example. This is going to be the summation or the series formula for a geometric that also is finite through the nth term. And then this formula is for summing infinite geometric, but only when your R is between a -1 and a 1, because then you have like a decay situation going on. So that is when we would use that one. So I'll refer to that as we work through these problems. So number 4, find the sum of the first 10 terms of the geometric series, and they give you the series. So essentially what I need to do is figure out what R is, and I know you know how to do this probably, but just a quick review. If you're not told that it's geometric and you want to test it, the way you're going to test to see if it's geometric is you're going to divide your values. But it's kind of backwards, so you divide -432 by +144, 144 by -48, -48 by 16. And then if you get a common ratio every time, you know that you have a geometric sequence. So I'm going to divide 48 or -48 by 16, and that's going to give me an R of -3. So I need to know that to get started. So we have our R of -3, and we want to sum through the first 10 terms. So that means n is 10, and this is going to be a finite geometric formula that we're going to look for. So we're going to be using this formula right here. Okay. Now this is one of the more complicated formulas. I'll leave that right there and fill everything in for you. So I'm going to be summing through. So sorry.
Brian Shanahan, Noah Ellis, and Alex Linden.
Okay, so summing through the 10th term. So I put a 10 in for the n. And I need to know the value of the first term at 16. And then in parentheses, I'm going to do 1 minus, and then use the parentheses here. Very important to use that. The power is 10, and all of that will be divided by 1 minus a -3. And it's fine to go and put a +3 there. So you can go ahead and combine in the denominator. The reason you can't turn this into a positive is because it's not a +3 to the 10th power. Is a -3 to the 10th power, which would actually turn positive, and then it's negated. So you get the wrong sign if you did that. So be careful with that. You have to raise the -3 to the power first, and then subtract that value from 1. So we have everything in place. Our starting term g sub 1, 1 minus our R of -3 raised to the 10th. Be sure to use parentheses there, especially for the negatives. And then I have 1 minus a -3 there. So I'm going to use my calculator, and I'm going to kind of show you how I walk through this process on the calculator. Okay, so there's a couple of ways you can do it. I like to kind of just do it step by step and not do too much all at one time. So I kind of go ahead and do this piece of it. So 1 minus, and then be sure to use your parentheses there. And then I'll divide that by the 4. And then I'm going to multiply that by my starting term of 16. Okay, and actually the last two steps could be done either way. Okay, so my answer is going to be -236,192. Okay, so just want to make sure you understand how to do one of those. And then number 6 says find the sum for the series. So first of all, what is this type of sequence? Is it arithmetic or is it geometric? And when I look at this, well, it looks like, you know, adding 12 there, but I'm definitely not I'm actually adding more than 12 there, but this is not going to be arithmetic. Is it geometric? Well, if it is, negative 54 divided by 18, which is negative 3, is going to do the same thing as 18 divided by negative 6. So R is a negative 3. So it definitely is geometric. And we're supposed to find the sum. And this little notation right here, this little notation basically means to continue on in that pattern forever and ever. So this is actually infinite. And because R is not a number between negative 1 and 1, I can't do this. I cannot find that sum. It can't be done. It's impossible. All right, so I wanted to show you one like that. Now, if this were flipped, and say it started at negative 54, and then went to 18, and then went to negative 6, then I would have an R of negative 1/3, which would be between negative 1 and positive 1. I could do that. So just be careful to make sure you understand what your R is and how to find it going backwards with your values. So it's sort of like putting this Y over that Y, then this Y over the prior Y. So it's working backwards. Okay, ones like number 9, you definitely need to be able to do. So let's look at number 9. So an amphitheater has 50 rows of seats and 30 seats in the first row, 32 in the second. So I'm going to kind of do this here. So 50 rows of seats. Okay, and we're supposed to total the number of seats. So I'm going to need to total through the 50th row. Okay, so N is going to be 50 because there's 50 rows. 30 rows in the, 30 seats in the front row, then 32. So my pattern is like this. So I have 30, 32, 34, etc. So really I'm going to be adding these together, but I have to go all the way out to the 50th position. Okay, so that's kind of what we're dealing with. So our common difference is 2. This is definitely arithmetic, but we're supposed to sum through the 50th. So let's look at that formula. It's going to be this formula right here. So let's fill in everything that we have. Sum through the 50th. That means N is 50. My first value is 30. I do not know the 50th value, so that's what I've got to find. So that's when I go back and I use my explicit formula. So I want the value of the 50th term in the pattern, and I'm starting with 30. I'm adding 2 every time, and of course I multiply that by 49. Okay, so just do that in your calculator and you get the value of that 50th term. And you get 128. So in the 50th row, there's 128. Now it's just a matter of plugging all this in your calculator. And you would have the calculator on this part, of course. So I get 3,950. So make sure you get that same value. So 3,950 seats. Okay, let's do another one. Let's do number 10. Number 10 is important. And it's not hard once you understand how to do it, but there's a little process on the back end. Because for number 10, we're always having this situation where you drop the ball. The ball comes down. Okay, and in this case, it's dropped from 20. That basically means the first term is a 20. Then the second term, it basically tells me I'm going to go back up 80% of that initial drop of 20. So you don't have to know all of these, but that means I'm going up 16, and then I'm coming back down 16. And this pattern goes on and on, okay? So that's what we have here. So this one obviously goes up, and then back down, etc. Now, it says that we need to find the total distance the ball has traveled by the end of the 6th bounce. So really what we're dealing with here is we need to sum through the 6th term. So this is definitely going to be geometric, and my ratio is going to be, if it's going up 80% of the initial height, my ratio is just 0.8. Okay, so I'm going to keep 80%. So the formula I'm going to use for this is going to be this formula right here, because I'm summing through the 6th bounce. So let me just plug everything in. So I have summation through the 6th term is going to be the value of the first term, which is 20, 1 minus my ratio of 0.8 raised to the 6th and then divide by 1 minus 0.8, which of course is just 0.2. So plug that in your calculator and see what you get. And you're going to get I got 73.78, so I have it on my calculator here. But what I'm going to do with that, before I do anything, 73.7856, I have to account for the fact that when I sum through the 6th term, it's really just the drops, all the drops. Okay? So what I have to do is I have to double it to account for when you go up. So I'm going to first double this, and I get a value there, and then I'm going to subtract the initial drop height of 20, because you can see there's not really an up part to this term. Okay, so double that and then subtract 20. You're just doing it all in the calculator before you even write down your answer. So the answer is going to be 127.57, and that's going to be feet, because I believe it's 20 feet. Okay, so that's the first part of number 10. The second part is going to be, what is the total distance the ball has traveled when it comes to rest? So this is actually summing through an infinite. Sometimes the infinity symbol is there and sometimes it isn't. But we're going to be using the formula, which is g sub 1 and then 1 minus r. So this is actually one of the easier formulas to use. So I'm going to basically say, summing through infinity, I have the value of my first term, which is going to be 20, and divide that by 1 minus 0.8 or 0.2. So again, just use the formula, and then I get 100. But I have to double that and subtract the initial drop height every time for these. So you're going to get 180 feet. So that is how you would do number 10. Okay, that covers everything, you know, that I really kind of wanted to highlight on the sequences and series part. And then I have a couple more that I want to go over. Let's go over 23 on the circled problem. Okay. Now, so it tells us our initial value is 12, the limit to growth is 30, and it's passing through this point. So it's really important that you understand what all that means. So if the initial value is 12, it's as if we have a point at 0, 12. Okay, and it also passes through another point at 2, 20. If the limit to growth is 30, that's telling us that the numerator will be 30. Okay, so let's kind of work this one out. We'll set everything up. So go ahead and plug in what you think that would look like. And it's a multi-step problem. So this is also going to be provided to you on the test. So that's really important for you to know. That's going to be provided on the test day. So I'm going to be using this formula here. So y is equal to the maximum allowed, or maximum, whatever it is you're growing or increasing, and then b to the x. So in this problem, it says the maximum is going to be 30, 1 plus, and a and b are my unknowns. But every time you'll be given this situation where you have an initial amount where basically your x is 0. So when I do a times b to the 0, it equals the y of 12, like that, okay? And the beauty of that is b to the 0 is just the number 1, so that just kind of disappears, okay? And then remember we have this situation where we can just reverse the 1 plus a, it comes up here, and then 30 over 12. So then I'm going to then subtract 1, so I'll probably just subtract 12 12s from each side, okay? And that's going to give me an a value, which is going to just be 18 twelfths, okay? Now, that would simplify down to 1.5, so that's fine to write it like that, okay? So there. Okay, so I had to pause the video to get let someone in the room. So I'm sorry if I kind of lost my place here. So let's find b here. And remember, we're going to basically just use our a value that we just found to do that. So we're still going to have a maximum of 30, 1 plus, We just found a to be 1.5, b to the second. And the reason that's to the second is because I'm using the point 2 comma 20. So x is 2 when y is 20. So I'm going to set that equal to 20. Okay, so this is how we'll find b. And then we reverse these two, and I have 1 plus 1.5 b squared is equal to 30 over 20, which is going to be 3 halves. Then I'm going to subtract 1 from both sides, and I'm going to get 1.5 b squared. 3 halves minus 1 half, I'm sorry, 3 halves minus 2 halves is going to be 1 half. And then I'm going to divide by 1.5, or remember this is really just 3 halves. So I can multiply by 2/3 on both sides. So multiply by 2/3. So I end up with b squared is equal to 1/3. So b squared is equal to 1/3, meaning that b is going to be the square root of 1/3. Or, if you want to think of it like this, I think this is easier, 1/3 is going to be raised to the 1/2 power. So let's put everything back in, because this is our b value here. So we have y equals our maximum value of 30. I have 1 plus my a, and my a is going to be 3 halves. I like to write it in fraction form. And then I have 1/3 here. And then remember, I still need an x. So the x is going to go in the exponent like that. So it's going to be x over 2. Because 1/2, if that value, so if it's b to the 1/2 and then to the x, you see how that simplified down to x over 2. So that's how that would look. So this is actually your final answer for that. Okay, that last little bit is a little bit tricky, but I feel confident y'all can do that. Okay, so that gets us a limit to growth problem using this formula here. So we've used almost every formula on here. So let's see what else we might need to do. Let's look at 74 on the back page. 74 on the back page. Now, because we have not used this formula. So the population of Metroville is 123,000 and is decreasing at this rate. Write a function that models the population as a function of time. Okay, so we are going to, again, look at our equations here, and this is the equation we're going to use here. And we just need to remember that this is either b is 1 plus r for growth, or b is 1 minus r for decay. So we're going to have a 1 minus r here in this situation. So 74, we're going to have the function is equal to the starting amount, which is 123,000, and my b will be 1 minus 0.024, and that's going to be raised to t. Okay? So that's how you would write that one out as a function or as an equation. So you would actually change it to, it could be population based on time, so you could say p is a function of t, something like that. Okay, so that was part A. Now part B says, predict when the population will be 90,000. So 123,000 is going to decay to 90,000. And we're actually given the rate here, we're just solving for the time. So we're essentially going to solve for that t right there, and we're going to use logs. Or if you have your graphing calculator, you could technically do it with a graphing calculator, like we learned initially. I think it's a little bit easier just to go ahead and solve it using logs. So, okay. So kind of simplifying this down a little bit, I'm going to divide both sides. Take 90,000 and divide that by 123,000. And that's going to equal to 0.976 to the t. Okay? So once I do that, I'm ready to take the log of both sides. And I can take the log or the ln here because it's not a base of e. So I'll do log just to kind of show you. And then I have the log here. And then the t will obviously come down front. So I have t times log of 0.976 is equal to the log. And then over here, of course, I can cancel these. So I have 90 over 123. And that's what we have. So I'm going to divide both sides by the log of 0.976. So this is the exact answer for t, okay? And then if I want the approximate, I'm going to do that in the calculator. So I'll show you that now. So I have log, and I'm going to do all this in basically all at one time. 90 divided by 123. And I missed my 9 in here. So you remember how you can insert, just to kind of review that. Do second, delete, and then you can stick in the 9 and you don't have to do it all over. You get that value and divide by log of 0.976, and you get time of 12.86. So it's going to be approximately 12.86 is going to be the answer there. And it was in years. Okay, so let's see what else we have. I think that that's going to be good because we've already done a limit of growth. We've already done a Newton's law of cooling. So I think that's going to get you one of each of the types of questions on the test that require one of these formulas, and that's really for the calculator part. So I hope that helped, and I'm sure y'all do great on the test.